Okay, I'm going to switch gears just because maybe I can see some smiles on your face if I run this. Let me see. So we want to do a little bit of computer graphics. So I'm going to skip over strings and show you how to draw some fun images. Okay, and then we'll come back to strings. So I just want to say, why are we doing this? First of all, we learn how to use libraries. You learn how to create graphics, which is always fun to see some nice images on the screen. You can use the ideas from graphics actually to control robots. You'll see why. And there's always, when you do graphics and robotic control, there's always mathematics and geometry there, right? So it's a nice way to learn mathematics and geometry. And it's cool that we can learn all this and have all this experience just by drawing some pictures, right? So let me show you. So the plan for this section quickly is, I'll show you a couple of commands and then ask you to draw something, okay? And then you draw something and then we'll learn a couple more commands. The beautiful thing here, this whole infrastructure was created with the idea that if I give you only like 6 commands, you can make very beautiful things. Combining Python programming, loops, and all these ideas we learned so far, and simple commands, you can make very interesting programs. Okay, so here are 3 commands. First thing is, you must import all the graphical libraries. You use this command called import. Import, we learned about import already. The library is called Turtle. And the reason it's called Turtle is it was created by this guy called Seymour Papert. And Papert was interested in figuring out how to teach people things, and in particular, how to teach children things. And Papert came up with this brilliant idea that if you have a physical object like a turtle, he actually designed a toy that was shaped like a turtle that would run on the floor. And you tell the children, how can you automate the movement of this turtle robot? And then the children would try to figure out how to make it move and how to make it turn, and they would play with it. And while they were learning to play with it, they learned a lot of ideas, right? So that's why it's called Turtle, in honor of Papert. So now let's see, so the question for me, which I'm experimenting now, is why not use turtles for adults? A lot of people think adults are too bored to have fun and play. So maybe you'll prove me wrong, okay? So you import. So let's look at some code quickly. You look at this turtle library, you import it, then you create a new turtle, right? And you can give the turtle whatever name you want. One of my friend's daughters wanted to call her turtle Taco. Since I was working with her for some time, I started calling all my turtles Taco. But you can give whatever name you want, right? You call it ABC or Tom or Jill or Jane or whatever you want. Give any name for your turtle, and this function here, which is inside the module. So I show you a different type of import. I import turtle as T. When I say import a file as something, this T becomes a shortcut. So I don't have to type the full word turtle every time. I can just do T dot and give me all the functions that are inside the turtle module. Okay, so T dot turtle, this will create a turtle. Then I can set its shape, so make it look like a turtle. Then I can give it a color, make it look blue. Then I can move it forward, left and forward. Okay, now do you think we're going to see any turtles on the screen if I run this? And the answer is yes. Can you see it? Okay, so why don't I think I put it so why don't you play with this? Can you all run it? Just get ready, then I'll give you a quick exercise. Everybody's able to run it, understand what to do.
So what are the possible shapes it supports, John? Like you said turtle. So there's a library.
There are other shapes, yeah. There's an arrow, there's other shapes. By default, it gives an arrow.
Okay.
But in honor of Papert, I always put the turtle. If you take off this turtle here and don't set the shape, try it. So let me show you. If I don't set the shape to turtle, it will have an arrow. Can you see an arrow on the screen now?
Mm-hmm.
And I felt it was injustice to Papert. We call the library turtles in his honor, but if you have arrows running on the screen, it seems strange, right? We shouldn't call it turtle and then have arrows. But yes, you can have any shape. Technically, you can have any shape. You can even upload your own images and make your own shape on the screen. Okay, everyone comfortable? You know how to go forward and turn and just two commands really, right? And color, you can pick your favorite color. It is kind of very clever with colors. It's a whole discussion how to set arbitrary colors. You can even do RGB values for those who understand what RGB means. Color is broken up into red, green, and blue. So you can specify those integers, figure it out. But you don't need that. It's pretty clever. If you say red, green, blue, yellow, orange, the kids always want to try turquoise. But you can try your favorite colors and see what happens. These colors will become important later, because you're going to create images with various colors. Okay. So let's go to the next slide. This is a quick challenge for all of you. Since you have forward and turn, can you make a square? and then we're going to look at somebody's code. Manish, you'll figure out the screen sharing, right?
Mm-hmm.
Yes, Mohit.
Can you hear me, Vijay?
Yes, yes, yes.
Yeah, okay. I mean, I see that there are functions like color, forward, left. How do you know what are all the available functions for, let's say, turtle?
Just do T dot and see what happens.
Okay, so that will bring up. And the other question I had was, these are ready-made functions, right? What if
Yes.
somebody wants to go and see behind the forward function how this was done? Like, how do you force the pointer to move forward? Is it done in a different language?
No, it's all done in Python. I mean, it's done in Python, but at the lowest levels. I mean, now we go down the low levels of the stack, right? Python actually, okay, at the lowest level of the stack is a screen. I'm going to go upwards from your screen. There are actual drivers that are written in C and C++ that interface with your screen, which is part of your operating system. The operating system functions are exposed to Python.
Okay.
And then Python packages into graphics libraries, which Turtle calls. And you call Turtle. So there's an entire sequence.
Got it.
But all of it is open. Yes, if you're interested, you can dig into it. Yeah. Make sure you, when you want to write this code, you please do what I did, right? You just copy over the import statement at least. By the way, I just wanted to say, if you do T dot right now, yeah, it gives you the options here, right? Or if you do taco dot, you see you do taco dot, then just give the editor a second. A little slow. I have included in this section a link to the full documentation. And if you guys are interested, next time I'll show you how to read the documentation, okay? See, you see, I did taco dot. Can you see this now, Mohit? You see all the functions that you can call. And there's even documentation. When you hover over it, if there's anything useful, it will tell you. Left, and it says turn the turtle to the left. You see it?
Yeah. And this is a feature in any Python IDE, right? If I click, it should be the available option.
Correct. The dot and the documentation is feature of any decent IDE.
Okay.
So Cassandra got the square. I think you want to share your code, Cassandra.
Yeah,
Then John, can you stop sharing for a second?
Yes. Yes. Stop share.
Oh.
Probably at the bottom of
okay.
your screen. Yeah, share screen.
Yeah.
Very cool.
Okay.
Oh wow, that's very cool.
I got confused, so I think it should. I should have left it 100, but yeah.
That's okay. That's only the size of your. That's only the size of your square. Now let me just make a couple of things on your code quickly. I love the color you chose.
Okay.
Now, one of the things I always like to do when I do a movement like this is you want to leave the turtle in the same direction as he started. So that means make one extra left at the end. So he's pointing when he started.
Oh. Okay.
Okay. And now, yeah. Okay, quick question. Is everybody having fun with this? Is this fun thing to do? We can do really cool stuff with it. Okay, so let me show you some important thing. First thing, Cassandra, is now the exercise for us is to make a function out of it. So you have done what comes naturally to, especially to beginning programmers, make it work. You made it work. Now we got to make a function out of it. Okay, so let's make a function. Just below this, you can write def, and then say make underscore square, and you put a bracket. Yeah, and inside the usually no space, Cassandra, between make a square. And, yeah, I prefer no spaces there. Okay, now inside this, what do you need to make a square? What measurements do you need to make a square?
100.
Yeah, which is the side of the square, the length of the square. So don't put 100. Give it a name, length or side.
Oh, okay.
Okay, so for now, let's do the length. Put a colon outside the length after the parents. Yeah, and come down. Yeah, it's automatically indented. Now let's take everything we need into this function. Copy everything from. Let's take the whole thing. Yeah, let's take the whole thing for now. Oh no, leave the import out.
Not the import. Okay.
Not the import. Let's take the whole thing and put it inside the function. And then you can highlight all the lines, Cassandra. You don't have to do one by one. Highlight all of them and hit tab. It should move over. Yeah, very clever editor. Okay, now we have to invoke this function. Delete the previous stuff. No, we got it below, so you can delete all that. Yeah. So if you run it now, nothing will happen. So let's just do make square. Yeah. Yeah. And then choose your, oh no, you have to put make square and put a length.
Oh, right. Okay. Oh, can make it different. Let's
Okay,
see.
wait. We're not yet done. So before you run this, let's look at our code. Did we use length anywhere?
No. Okay.
So everywhere you see 100, we got to put length. Just copy length once and you can paste it every time.
Okay.
Excellent. Make square 100. Now you see the benefits already. I can create as many squares as I want if I need to. Yeah. And I can change the 100 now easily, right? Don't have to change it in 5 places. Okay. We can do better. Why do we have so many repeated instructions? Forward, left, forward, left. We have so many repeated instructions, right? So when do we write a for loop? How many pairs of forward lefts do we have to do? 4, right? So put a blank line there. Yeah. And do for. Yeah, make a for loop. For
Oh.
For I in. It's a for loop.
Oh, for I. Oh, sorry. Okay. For I.
In range what?
In range what? 1 through 4?
Yeah,
4.
yeah. Try 4.
Okay.
Try range 4. Let's see. No. I in range 4. And 4 has to be in brackets. Okay. And then you have to indent all these things. Okay, just take the first 2 lines. First 2 lines. Yeah. Put it inside the for loop. Yeah, just make sure the indents are good. And delete the whole thing after that.
Last.
Yeah.
Okay.
Very cool. Isn't that much nicer and compact? Yeah, okay, hit run. Let's see if it does.
Oh, no.
We have 1 indent extra on the left.
Okay. Right.
Careful. They're not, yeah.
Oh.
Yeah, they're good now. All right. Does everybody see this? Okay, I want this protocol, this process to become second nature for you, right? That means you do this naturally. Make it work and then make a nice little function and use loops to eliminate repetitive code and clean it up. Okay, there's one more trick I can show you, which I think is important. You can take can we make color into a variable? Sorry, before you leave, Cassandra.
Okay, yeah.
Make color into a variable as well. Length, comma, color. Oh, on top. No.
Okay.
In your function. So we can now have squares of all color, right? You just have to change the color. Yeah, and put where you see purple, just put color. No quotes though. It's a variable. Yeah, and now on your make square, you have to pass in the color as a string. Oh, below, all the way below. When you call the function. You have one more parameter.
Okay.
Yeah.
Like,
with quotes though.
okay.
It's a string. Okay, run.
Oh.
There you go.
Okay.
Okay, it's very cool, right?
Yeah.
Okay, so let's get back and I'll show you a couple more things. And now with that extra stuff, you should be able to do a lot of very powerful stuff. So there's just 2 more commands I need for today and then you're good. One is these shapes are empty, right? The space inside is white. Suppose I want a fully filled pink square or purple square. You just put this, whatever your turtle's name is, Taco or whatever. I forgot, what was Cassandra's turtle again?
Taco.
Taco, yeah.
Taco.
Yeah, give it your own names, okay? Have fun with choosing names. But you do taco.beginFill and taco.endFill. Okay, if you do beginFill and endFill before you start a bunch of drawing operations. So on either side of your for loop, if you put a beginFill. So you look at my code here, you see here, I have some for loop here. On either side of the for loop, I do beginFill and endFill. Okay. Now I want to tell you, I did one more extra piece of work. I took the turtle and I said, I'm not going to create the turtle inside the function. Let somebody create the turtle outside the function and pass it in to me. Right? So the turtle becomes a parameter. The turtle gets created and somebody has to give me a valid turtle. Then the code will use the turtle to draw it. This is always nice because then globally I can control how many turtles are created rather than telling each function go off and create your own turtle. Nobody's allowed to create turtles. They want to conserve the population of turtles, right? So I have centralized control of turtle creation. Every function is, this is the idea we talked about in list. Do you make a copy or you not make a copy? Here, nobody's allowed to make copy. Use my turtle, okay? But this function is actually more powerful than what we just saw. It's called draw polygon. In what is a polygon? A polygon is actually a beautiful thing. It's a special class of geometrical objects where all the sides are equal. So the square and the equilateral triangle, the first one is 3 sides are equal. Square is 4 sides are equal. What's the next one? 5 sides are equal. Does it have a name? Pentagon. Pentagon, right? Because penta is 5. Hexagon is 6 and so on. Septagon, octagon, you go on, right? So I wrote functions with the kids to make 4, 5, 6. Then I said, no. Can we write code that can find any n-sided figure? You just tell me n equals 4, it will make a square. You tell me n equals 8, it's going to do an octagon. Okay, and the code that is in this thing is actually an octagon. Now, if you take a paper and you try to figure out, there's one interesting question here, which is how do I specify the turning angle? If I know the turning angle, then the rest of the code is easy because I just have a loop that does as many sides as I need. But the turning angle, you have to figure it out. It turns out to be rather simple, but please derive the turning angle. And if you can't figure out what the turning angle is for a general shape, then ask me. Okay. Now you can run this code. If you do this function draw polygon, it will draw. But I did a little bit better, and I want to show you this now. And you tell me if it's cool. I'm going to actually create a logo for a company, right? And use this turtle drawing to make a logo. So tell me if you like the logo for this company. So it's just basically that. So the idea here, as you watch it drawing is, the idea is you take any idea you have, you decompose it into a bunch of simple steps, and you code it, and you let the magic happen, right? And you can produce extremely beautiful images by just thinking about it carefully. So what is this particular thing doing? It's just drawing hexagons. And it's drawing hexagons by making them smaller and smaller and smaller. And it's actually alternating between an orange hexagon and a white hexagon, right? Does it look promising? Anyone thinks that this is an interesting image? Yes? Okay. But I have to give credit to someone. I was working with a kid last week and he made this on his own, right? He learned about hexagons, he learned about changing sizes, and he put it in a loop and he changed the size, and I showed him how to do loops, of course. So why did I say all this? I said all this to say creative image making is within your grasp, but you have to think like this, right? Say, think what tools I have. Oh, I can draw polygons. Okay, can I make them bigger? Can I make them smaller? Can I rotate them? Can I move them? And then you start drawing and you get all kinds of stuff. So you take a nice blank piece of paper, you sketch out what you want, and you convert all of that into code. Make sense? Okay, okay, what do you think? Good logo? So you can save this as a JPEG file and then use it as a logo for a company, right? If you design your own logo, right? So it's simple. Let me just now show you one more, just because I have to show you some cool images, right? So you guys get excited. The code for all these images are here. Let's run this while I'm talking about it. So I'm going to build another nice little idea. I take equilateral triangles and I rotate them each time by a fixed amount. And I change the color every time I rotate them. Simple idea. Logically, it's a simple idea, isn't it? When this guy finishes drawing, you'll see visually, you tell me, does it look pretty? Can you tell me in chat if it looks pretty or not? Okay, people like it. Very cool. Yeah, so does it motivate you? Hopefully this is fun, right? Just like you're writing other types of code. Now you can ask, how can I make different types of images, right? And I'm taking the luxury of showing you this. I want for this week, your basic project is to think of something interesting and draw it. Okay, I will come back to strings in this time or next time, it's not a stumbling block at the moment, but I want to leave you with the tools to draw these cool images. Maybe that'll get you excited about sitting. And remember though, the idea here is very important. I'm using for loops and all kinds of programming techniques to get this to work. If you try to do this by hand, you'll be sitting there all day because there are like 60 triangles in here, right? So if you want it to go fast, you want to probably figure out how to write a nice program for this, right? I won't let it finish. Okay, I just want to save time. I'll show you. I'll just show you one more thing. Then we're done with demos. These are just graphics demos. Please look through the code, and of course, ask me if something is not clear. Yes, you can change the speed of the turtle. So
Okay.
sorry, I should have done it right away to save time. Can you see this line here, line 17?
Oh, okay.
Okay, there's a speed number. You can, and the speed, if you set it to 0, it's the fastest it can go. We can just take, well, you can try it. Okay, use the speed. So now I'm going to show you something. This was a very, very big surprise to human beings, because in the 60s, with the advent of computers, we went and we asked a question. We see complicated patterns in nature. And if patterns are complicated, are the rules that produce complicated patterns complex? And the surprising thing we found by playing with computers and analyzing these things is the rules that make complex patterns don't have to be complex. As Rabindra said, fractals. So this image is actually a fractal, right? So that's why I'm drawing it. And what is a fractal now? A fractal at the highest level is an image where every sub-image is similar to its parent. And as you go smaller and smaller, you see the same structure. It's a self-repeating structure. Okay, you may not see self-repeating structure here. As soon as it finishes, I'm going to show you why it is self-repeating. Okay, and what is very interesting is that we found that nature has a lot of self-repeating structures. For example, if you look at a cloud, it's kind of fuzzy, right? Or you look at a tree. From far away, it looks like a green shape. You go closer, you see some self-structure. It looks like a branch. You look at a branch, it's got smaller branches inside it. Look at a branch, it's got smaller branches until you end up with a leaf, right? So this kind of nature produces a lot of structure at different length scales, smaller and smaller and smaller. For example, there's a beautiful question that's asked. If you look at the coastline of a country, like Cassandra's in Germany, if you look at German coastline, then the coastline is, okay, you can see this fractal. Is it cool? Yeah, so now why is this a fractal? The answer is very, very simple. In this fractal, it's a fractal which has 4 levels. So if I start with level 1, this is the most basic fractal. It's a simple thing. It's just a V. It's 3 V's. Sorry, there's a straight line, a V, and a straight line. If you look at the left of the triangle, then you rotate it. There's a straight line, a V, and a straight line. Then you rotate it. There's a straight line, a V, and a straight line. Right? So it's 3 V's rotated around an axis. Now you take each of the straight lines and you replace it with a V. So for example, if I go depth equals 2, each of those straight lines gets replaced with its own V. So I want you to run this for different levels of depth and see what is happening. And then if you go level 3, each of these V's, you see a little V here, for example, this V gets replaced with another, each straight line gets repeated at smaller and smaller. Take every straight line and make it broken up. I don't want to beat fractals to death, but I wanted to show you the important idea that complex patterns can be made with simple code structures, and using programmatic constructs to repeat it. Look at my structure here. I have 29 lines of code, including some spaces, right? And I've created a fractal pattern. So that should encourage all of you. The way we have structured this, let me get through this and we can come back and we can go back to strings for a minute, is if you go in here, I have given you some project templates. I've given
John, we are way past our class time.
So let me finish here. We can cover strings in one of the extra sessions next time, the beginning of next session. Let me finish up this assignment and then take some questions. So what's in here? I've given you some templates for things that you could try to draw. I have only included images here, right? So this is a challenging assignment. Hopefully everything I've said so far motivates you to try. I've given you can draw anything, right? But I've actually given you 2 examples. So if you look at this, here's a drawing that I have made, right? Can everyone see the picture? So you can see this pictures made up of very simple shapes. There's a circle, there's a square, there's blah, blah, blah. So you can use your imagination. I gave you something to help you think about it. And you can try to draw this image. There's another one which is kind of little bit more maybe cool, right? And there's one extra function you need. I've given it to you here. It's called stamp. You can try this function out. But why are these two examples here is basically to tell you that just use your creativity and write some code and make a nice image. And then you can actually submit this code in here, right? So you should be able to submit your code. Either paste me a link to your trinket or copy it into here or upload a file, whichever way you want to submit it. Okay. And next time we will showcase all your creations and discuss it. And if you have questions, you can send me email and we can talk about it. But let me ask quickly on chat, is this a fun thing to try to do? Somebody say yes, no, maybe? Yes. Okay. Okay, so everyone will try? Are you likely to try more because there's now nice images and so on? Is it something that makes you more motivated to try to write some code? You can see some interesting pictures. Okay, but the skill here is important. Think of the picture, break it down into its components, and then draw each component. And the nice thing is you can keep on seeing it on the screen as you work on it. Set the speed to 0 if you want to speed up the drawing.